Hello, everyone, and welcome to today's webinar. This is Sydney speaking, and today's webinar is sort of a continuation from our last one of what's new in SolidCAM 2019, but this time we'll be dedicating it to iMachining, which we have our biggest enhancements that we've ever done ever since iMachining was actually released. And giving this webinar will be the CTO of our company, of SolidCAM, Anthony Calderon. But before we start, I'd like to also remind everybody that we also have SolidCAM World coming up very shortly. So if you have not registered yet for it, please sign up as soon as you can. It's important to make sure we also have enough rooms for everybody. And there's a full venue of what we'll be doing there. There'll definitely be something there for everyone who attends. There'll be a lot of information going on during the SolidCAM World, and we'll also good chance to meet everybody while we're there. And trust me, nobody will be disappointed, whoever comes. Okay, so let's not waste too much more time now, and I'd like to make Anthony the presenter. And of course, I just want to remind everybody that this is being recorded, and the recording will be available later on after the webinar is done. So Anthony, I will make you now the presenter, and you can go ahead, unmute yourself and show us your screen.
Okay, thanks, Sydney.
You're welcome.
Share my screen. Make sure I pick the correct monitor here. Sydney, I hope you can see my monitor with.
Yes, everything is perfect.
With PowerPoint. Awesome, great, thank you. All right, hello everybody. Thanks for joining the webinar. This is definitely an exciting webinar for myself to give and all everybody in the iMachining team. So I'm gonna go through the what's new a little bit with iMachining. I'm going to kind of start from the back of the what's new, because the first portion of the what's new is the iMachining feature recognition stuff, and obviously that's the big thing we want to show here. So I'm just going to touch on the little things at the end real quick, and then we'll get to the fun part. So two little things we've done in iMachining 3D. Now in iMachining 3D, we have STL holder support. This is not something you're going to really, there's no checkboxes, there's nothing new in the interface. It's just now, it's now supported. So now if you have an STL holder, the collision detection will work from this. It's important to know that this is actually working by creating a envelope of the tool holder. So if you have a round tool holder like we have here, you get the envelope of the holder. If you actually try doing something like a mill turn holder or something like that, we will take the envelope of that. So if you do try creating some complex holder that's not cylindrical, it's like rectangular, you might think that maybe SolidCAM should be cutting more material than it is, but we make an envelope of the holder. It's not actually, and we do this for speed. So just be aware of that it is an envelope, and now works. And I think this is, it's not a huge, it's not the world's biggest thing, but we've definitely had this request over the past several years to support STL holders. iMachining 3D, we've also added an option to limit the depth of cut to 1 ACP. So I actually have a part here. Let me close this file. Okay, so I have just a simple example here. It is the example from the what's new, and what we will do is let's just play the simulation one time. And this option here is all about the cutting at the CNC. So what we end up with when we're cutting with iMachining 3D is we get our step up along along our model. Now what happens is, when we start at the bottom, we have a lot of the tool engaged with the material. And then as you step up, we end up with less and less of the tool engaged. And at some point, you really end up with just a very little bit amount of the tip of the tool engaged with the material. And what this can cause is chattering, and it can also damage the flutes of the end mill. So if I were to open up the iMachining operation, let me just open up the help file because there's a really nice picture in the help for ACPs. So I think everybody's aware of ACPs and iMachining because it's one of our big things. So the ACPs are the amount of flutes that are engaged with the material along the length of the cutter. So now what we have is if you end up in this situation, and let's say you have a hard material and you have a tool that's starting to chip, you can now limit the depth to 1 ACP. So for this end mill here, let's see, what is it? It's a 10 millimeter end mill. On this 10 millimeter end mill, 7.8 millimeters is the minimum amount of engagement with this tool. So that way we have 2 teeth in contact, and which would, get rid of our vibration. Anything less than this, and you start to end up with a vibration in the cut. So if I were to just calculate this operation with the depth of cut limited to that, you can see over here in the wireframe toolpath that now it's adjusted. And I mean, we can always relaunch the simulation and show it here. I'm using the new record option. That way I can use the slider to drag back and forth. So you'll see as we step up, once we see that the step up is going to be less than the 7.8 millimeters, we stop the tool path. And once again, so this is all for the cutter at the CNC to make it happy. I don't, if you're cutting aluminum, obviously it's not going to be a problem. But if you're cutting, if you're cutting some hard material and you're having problems with the tip of the end mill getting chipped, you can use this option. And then, I mean, it would be left up to the customer to, let's say, pick a different end mill. You could pick maybe you have maybe you want to rough the part with your good quality, end mill, and then you want to come back with like the same size tool that's maybe a little bit more, general purpose, because there are different end mills. There are end mills that are, good for iMachining style cutting, and then there are end mills that are a little bit more generic, that can take a little bit more abuse, but don't cut as well. So you could use an end mill like that to try and remove that rest material. Okay, now let's go to the fun stuff. So iMachining feature recognition. For us in iMachining and our team, we really feel that this is the biggest thing we've added to iMachining since we came out with iMachining. There is, this isn't a new style of toolpath. It is still the iMachining style toolpath. But what really is different here is that how you program in SolidCAM is the difference. When we came out with iMachining, I think the biggest change there was that on the machine, it cut like no other toolpath. And this was what makes iMachining unique, is that it does something special at the CNC, which gives you lower cycle time, extended tool life, and all of that is happening at the CNC. When you use iMachining in SolidCAM, okay, you see a different toolpath, but for the most part, it more or less functions, like existing toolpaths. You're picking change, you're picking upper level, lower levels, you're picking your tools. Everything is kind of reacting very similar to any other toolpath in SolidCAM. Maybe the bigger difference, that we've done with iMachining is it has the technology wizard. So, which once again, the technology wizard was to help the cutting at the CNC, because we knew from the beginning of iMachining that we needed to give good feeds and speeds, good cutting conditions. We needed to be able to show people, okay, if you're cutting with, a 12 millimeter tool, or if you're cutting with a 1 millimeter tool, how are you going to get the good results at the CNC? So we made the technology wizard. Now we come to the iMachining feature recognition, which this doesn't change what happens at the CNC. This is changing what's happening in SolidCAM. So this is all about how fast can you program in SolidCAM? How easy is it to program in SolidCAM? So now, for us, this is why we say this is our biggest enhancement to iMachining. We really felt we solved the problem of the machine, and now we're trying to solve the problem of the software. And this really has been something that we envisioned from the very, I'm not going to say the very, very beginning, but I mean, within a year or two of us, putting iMachining out there, this was kind of our goal. Our goal, and I mean, for anybody that knows Mickey, Chris, Mickey, and I, we've talked about from the beginning clusters of tools and being able to, say, hey, I want to use these 3 tools to machine a pocket and to do the roughing and the finishing and everything, and for the software to manage that instead of the user having to manage that. So we've built all these kind of, we've done these building blocks in SolidCAM through the years. We've done iRough, iRest, iFinish. We started finishing the floors. Then we started adding pocketing style toolpath for finishing the floor. Last year, we've added a multi-tool. So in one operation, you can do, as Mickey called it, clusters of tools, but it's multi-tool in SolidCAM. So you can define multiple tools for roughing and finishing that geometry. And this has now all brought us to be able to do the iMachining feature recognition. I'm pretty sure everybody here has already watched and gone through the PowerPoint and seen some of the videos. So hopefully, when I skip over things, everybody's going to be aware of it because they've seen some of this stuff. So I'm not going to go through the PowerPoint word by word. I'm going to skip over some things and jump into the software and kind of showcase what's going on a little bit. But the main things with the feature recognition is there are now 4 geometry definition modes. So we have feature recognition by faces, feature recognition by chains, outside feature recognition, and chains without feature recognition. So feature recognition by chains, or by faces, we get to just pick on faces, and then we figure out what to machine from those faces. And the face selection is done directly from inside the operation, so we don't have a separate, we don't go to a separate geometry definition dialog. You can do it right from inside the dialog. We have feature recognition by chains. So this allows you to do things where you don't have a face to pick on, like a floor. So through pockets is one example, and also side profiles is another example. Outside feature recognition. So this just allows you to take the outside shape of the part and machine that. So this one is pretty nice. And then chains without feature recognition. So this is the existing way that iMachining 2D works. And so even though we have all these new feature recognition things, which are using the stock, the target, the fixtures, smart face, and all these things in SolidCAM, you can still use the just purely 2D chains. The customer can define the upper level, lower level. You mark what chain is open, closed. This thing allows you to like gouge the model and do things like that. Let's say your model doesn't, have, the model's not done to the tolerances of the 2D print. So in the old 2D iMachining, it doesn't look at the target. It just looks at the chain. You can apply negative and positive offsets to it, and you can just cut. So, so we have the existing iMachining 2D. You can just fall back on at any point. So we're not removing the way the software worked in previous versions. We've just extended it for new features. We have, and I'll show some of this. We have dynamic previews, which is really nice. I'll show you as I go through the demo. I'm going to show some of that. There are a lot of CAM settings, and I would say, for I think for us resellers as demoing, let's say the default SolidCAM, I think the settings are set up really good. But for customers, as they program parts day in and day out, and they do a lot more programming than we do, on the technical side, they might want to remove some of the nice previews and stuff we do. So there are CAM settings where you can change the geometry preview mode from get rid of the 3D to just 2D. You can even turn it off entirely. You can also change the default geometry mode. So, I mean, you might run into customers that are like, hey, I'm used to working with the old chaining method. That's my default method. And when I want to use feature recognition, like by picking on faces and stuff, I'll do that specifically. So they can set that the default geometry mode in iMachining 2D can be the legacy chains, as we call it. When we have semi-open pockets, you're going to see, I don't think in my demo here I have something that really shows this, but this is important to know, that there's two styles of extensions. So if we have this semi-open pocket here, the extension can either be done tangent, so you can see it extends tangent from the end of the chain, or we have closest point, which is we find the closest point to the stock, and then we put a little fillet in there, so that way it has a nice transition. So these are two different styles of extending of semi-open pockets. And there is also an option for the preferred default extension. As I said, we tried to put a lot of CAM settings in here so that we didn't know exactly how people would use the software, but we wanted to be able to give people the choice to change some of the defaults in the software. So you can choose the default extension for closest point or tangent, and then we also have an option for switch to tangent for simple geometries. And these are geometries that consist of a single opening with closed islands, no semi-open islands or anything like that. So now let's get into the fun part of actually using SolidCAM. Now we have this part here. I don't know that this is actually a part that looks like a customer part, but this has it's a multi-sided part, which is really good for showcasing all of the feature recognition stuff we do. I'm pretty sure that most of the customers we deal with are gonna probably say, my geometry's not, I don't end up with so many weird conditions like this type of part would show. But I think even in simple 3-axis parts, you end up with little things like this. And it's really important to see the power of what we do, so that way you understand how to use the software. So I'm going to turn on the updated stock, so we can kind of the initial updated stock is new for 2019. I think Sid went over this in his demo. You can now see the initial updated stock before you even start programming. So this is helpful, so that way as a user, you want to start thinking about, okay, what do I want to machine first? I am going to create a 2D iMachining operation. Slide this over a little bit. So here you can see, our new toolbar. So here's your feature recognition mode toolbar. So we have the feature recognition by chains. We show the little red face for by faces. So we have the red face for picking faces by chains, and we highlight the chain, outside cutting, and then chains without feature recognition. So we have here this little list box, so we can begin selecting faces. So I'm just going to come over here. I'm going to pick this face. When you click back in the operation, you can see you get the preview of the chains that were found from that face. Now we're going to go select our tool. So I have a 20mm end mill here. Once you select the tool and you have a face selected, you can now see we get a dynamic preview of the machinable feature. So what does it mean when we say machinable feature? In other softwares, a lot of people talk about feature recognition. Even in SolidCAM, we have feature recognition. So feature recognition is saying, okay, let's look at the model and let's find some feature on the model that we want to machine. And usually this is finding, pockets, floors, holes, things like that. With iMachining machinable feature recognition, what we do is we say, okay, what is the feature from the model, which is this face, and we find the chains for that face that would say, okay, if we wanted to machine that face, what is the boundaries of that face that we're going to machine? And then we say, what does the target model look like? And what does the stock model look like? And also, what does the fixture model look like? So we take our pocket, we will protect against the target. So in this case here, you can see we have this this undercut. So we have this little ledge that's hanging over. In something like a normal feature recognition, you might click this face, and then it would just gouge this overhang, and it would cut it away, and then you would have to deal with it. And the machinable feature recognition that we do, we say, okay, well, we can't machine that portion of the geometry because it would gouge it. And then the other thing we do is we then extend the region to the stock, because as we know in iMachining is all about smart cutting at the CNC. And with the smart cutting at the CNC, we measure every engagement angle for every single point of the toolpath. The tool never plunges on material. All the lead in and lead outs are done, in air. All the repositioning is done in air. So when we did the feature recognition for iMachining, it's important that we took into account the stock automatically. And I think everybody, who uses iMachining 2D today knows if you wanted to cut this face and you had this much stock on the left-hand side, the only way to solve this problem would be sketching in SolidWorks or in Inventor Cam. So you would have to, start a sketch, you would have to offset this to the stock, you would have to trim up the lines and do that. Now with the iMachining feature recognition, we do that automatically. And this is probably where the most amount of time savings is going to happen once when you initially program, and I think also as you start to change things in your program or for associativity, because now we're just picking what face we want to machine. We are kind of doing, let's say, sketching in the background in SolidCAM. So we automatically kind of do the sketching that a user would do, and we do it for them. So if the stock changes, our sketch updates. If the customer was doing that manually in SolidWorks or in Inventor, then you would end up having to fix their sketches all the time. And I think we've all seen, I've seen customer files where for every geometry they have in SolidCAM, they have like a sketch over here for each geometry. That way they can be very organized and very clean, and if they need to modify it, they can deal with that. So with the new feature recognition, you get away from having to do that. I'm going to say, let's finish the floor on this, and let's calculate our toolpath. Now, when you calculate your toolpath, you're going to have to use certain tools inside of SolidCAM to review how the toolpath cut and if you're happy with everything. So now in SolidCAM, which is, let's say, very, very different than it was, 4 years ago or even 3 years ago, there's lots of different ways, tools that you would want to use. So first being, you might want to turn on and off the toolpath display. So after you calculate the toolpath, you might go, you know what, I want to turn off the toolpath so I can see the result of the machining. We also have, with the feature recognition, you can disable the preview that we do. So if you want to see, okay, I don't want to see that little 3D preview that SolidCAM does, I just want to see the stock, you can also hide and show the updated stock from the tree. You also have the option to include current operation in the updated stock. So maybe when you're looking at this operation, you would say, okay, I want to view the updated stock, but I don't want to see what the end result of this operation is. And then in that case, you can see what the machinable, you can see how it's extended up to the stock, and you can see what it looks like. And then the third thing would be to simulate your toolpath. I think now in 2019, I think the best way to simulate your toolpath is with the new simulation. I have my speed turned all the way up. I use the record option. This is nice for reviewing, okay? Because now that it's recorded, I can drag through my toolpath. I can see what's happening. We can go from the very beginning and just see how the tool is entering and exiting the cut. So once again, we automatically extend the geometry to the stock, so that way we're plunging out in air and you don't have to do sketching. So you know, you can see here by coming to the beginning of the toolpath, we can see that it's, you know, correctly from the outside of the material right through. What's kind of nice is we can use the stock and target comparison, so we can see, okay, we're still in roughing, and then eventually, as we slide through, we're going to start finishing the floor. So this is nice. You start seeing the floor being finished, and there's your toolpath. So as I said, this is definitely something that I think customers are going to have to get used to, is that now you have many ways to preview the result of your toolpath, and to understand what the toolpath is going to do. And this is, you know, as I said, it's from, you know, you have the toolpath checkbox, you have the geometry for the updated stock that you can turn on and off. You can either include the current operation in the updated stock preview or not include it. And you also have the geometry preview for the feature recognition. And of course, you now have, you know, you can use the external, you can use the old Solid Verify, of course, but you also have the new simulation, which, you know, if you're using dual monitors, you know, I do have dual monitors, but not sharing it through the GoToMeeting. I would be keeping this, you know, the simulation open on my second monitor, so that way I can be, you know, seeing what's happening here in the simulation, while at the same time seeing, let's say, this 3D preview and stuff. And I think this is going to be something customers are going to have to also learn. You know, from our side on the demos, and I can't say exactly how demoing is going to work with all this new stuff, but you know, for each of you guys, when you demo now, I think you're going to have to find a nice workflow that allows you to demo these features, and let's say turn on and off some of these, you know, all these dynamic previews we do to get the point across to the customer. Because I think existing SolidCAM customers understand all this stuff, but if you're demoing to a new potential customer, maybe this is a little bit of overload. You know, it's a lot of information we're kind of showing on the screen here, and as a demo guy, you're going to have to try and find a good balance between what you want to show and how to explain to the customer what he's seeing. So it's just something for you guys to think about. The other thing you can also see with the geometry preview that we do show the upper levels and the lower levels automatically and out on the screen, so you don't have to go over to the levels page to see what's going on here. All right, so I'm gonna say I'm happy with that toolpath. Now what I want to do is, let's say I want to machine this through pocket. I'm going to add a new 2D iMachining operation. This time I'm going to use our feature recognition by chains, because I don't have a face that I can just pick on. I pick my chain just like a normal pocket. I need to go select a tool. So I'm going to rough this pocket with this 20mm tool. I already know that I have a smaller corner radius in here, so I need to pick a little bit smaller tool to finish this pocket. Now that we have multi-tool in iMachining, we can just pick this. We can just pick this 10mm tool, and we say, hey, I want this. You know, I want that 10mm tool to finish the wall. We can calculate our operation. As everybody knows with multi-tool, even though you're defining multiple tools in the same operation, you get multiple operations out in the CAM tree, so that way you can do your reordering. Once again, as I mentioned, you're going to have to learn how to use all of these previews and stuff to show what you're looking at. So the first operation we have here is the roughing. You know, we can see that it's rough helical, helical entering into the pocket, roughing it out. When you do the preview and you click between these, you can also see, pretty neat, you will see the 3D preview update based on what tool is active in the multi-tool. So when we're highlighted on the first tool, you can see that the preview shows the entire pocket, right? Because we haven't machined anything with it. When you click on the second tool, which is doing rest machining and finishing the wall, you can see, hopefully it comes through the GoToMeeting. It might be a little, some of the colors might get washed out a little bit. You can see that we just have material in the corner, and then there's some material on the wall.
Anthony, what I really liked about this in particular is that it also shows you that the upper level is automatically calculated from where this previous stock was left over. That's really nice.
That is correct. That is correct. And now you're gonna steal my thunder a little bit, because now I'm gonna show something pretty cool.
I'm sorry.
No, that's awesome. No, it's cool. So we can see that the heel said it started from this top face because we already machined it. What if we didn't machine that face? What if this first operation here, that we took this and we drug it down to the bottom? Now, when we open up this through pocket, what do we see with the preview? We now see the preview automatically changes the upper level to the highest point of the stock. So, and if we drag my, let's see, what do we want to do here? Well, let me drag that while let's take well, it's not letting me drag it at the moment. Okay, so as we see here, the updated stock is done from the highest point. And once again, if we look at the, if we look at the levels, the upper level is found automatically. Since this is a through chain, we're machining right to the bottom. We can also add a delta depth and machine a little bit past. Now, obviously, I don't want to cut that way, so I'm going to take these two operations, drag it back down. Let me calculate each one. And if we like, we can go to the new solid simulation. Simulate both of these operations. As you can see, I really like using the record option because it's nice to go back and forth with the slider. So, we can see the first operation is roughing the pocket, and then we can see the second tool is coming in, cleaning out the corners, and cutting accordingly. Okay, so now we can see everything that's being cut with this. Now, the fun part about the way the iMachining feature recognition works is it's a little fun to try and decide, okay, what am I going to machine next? And I think when a customer is dealing with a multi-sided part like this, like a 5-axis part, and maybe even a 3-axis part, this happens. As a programmer, you're asking yourself, okay, what tool am I going to use? What features do I want to machine? Do I want to machine this face first? Do I want to machine this face first? And you're trying to decide the sequence of machining. So, and this is where, in the end, iMachining is not deciding the sequence of features on what to machine. The customer is deciding this. And I think a lot of times, as you start to program your part, as you start machining it, you decide to make different decisions. So you go, oh, I was machining, this face, then this face, then this face. And then as you went along, you're like, what, out at the machine, maybe this caused some chatter or some problem. Maybe you wanted to drill these holes first before you machine that face. And now with the new stuff, you can just reorder your operations, and you don't end up in a situation where you have to then go figure out all your upper levels and lower levels again. You don't have to worry about fixing your sketches. All of that stuff will happen automatically for you. In this case, I want to machine the outside of my part. I mean, let's be honest here. Probably if we were doing this for real, we would have machined the outside of the part to begin with. But part of the demo was I wanted to make sure I showed you how we extend the pocket to the stock. And if this or there was only like, half a millimeter on it, it would have been hard to see. So I'm going to pick 2D iMachining. Now we're going to pick outside feature recognition. When you do outside feature recognition, you don't have to worry about picking any geometry. I am going to go select my tool. I have a long flute version of my tool, so that way it has enough flutes to cut at one time. You can see the preview automatically pops up. You can see that it's cutting from the stock to the target. You can also see that we're machining right to the very bottom of the target. If we like, we can put in here like a -2 millimeters just to machine a little bit beyond it. Save and calculate. The beautiful thing here is the preview show you what's going on. So I mean, zooming in on that, I was able to see without even calculating a toolpath. Oh, I forgot to go a little bit deeper to machine that away. We still have all the existing old tools, in SolidCAM, and I'm not going to use the term old, just our previous tools. So if you want to use the Solid Verify, you can use the Solid Verify. Now that we've machined that, now what I want to do is I want to machine this face here. So I want to come from the side and I want to machine away this material. And eventually I'm going to want to do it on this side, and I'm going to want to do it on the opposite side. So we'll add a new 2D iMachining operation. And one thing you'll notice is I really don't use copy and paste now. I think you absolutely can still use save and copy and paste, but like the iMachining operations are so well defined and so easy now that it's very easy just to create a new operation every time. Pick your geometry. We find all the levels for you automatically. Pick your tools in Multitool, which is really easy, and you more or less have your operation all set up. So, I'm finding myself, I use save and copy less with all these new tools, but you'll also see I use save and copy later on here, but it's just something for you, to think about as you're demoing that, I know we always try and use save and copy because it makes things look faster, but it's really, a lot of times I don't know if it's really that much faster, but just something to think about for you guys. So I'm going to use by chains, and I'm talking at the same time, so I need to pick my other coordinate system. So I want to machine from direction. I'll use tangent with up the entity to pick our geometry there. I am going to pick my tool. I have a longer reach tool. It's got a little bit longer reach to cut, to reach through the part and to clear the fixture and stuff. Now, since we are using feature recognition by chains, it's up to us to pick the pocket depth. So I know I want to machine, let's say, past this bottom point of this fillet. So for me, maybe I'll just pick this vertice here. I mean, you could have picked this thing and put a little delta depth, whatever you'd like to choose. I mean, the cool thing here is you can, zoom in on the preview and you can kind of see, okay, how does that work with, clearing the previous operation stocks. So I'm just going to calculate this toolpath the way it is. Cool, looks nice. You can see, which is really, these are little details that I like, but I think is, maybe as we're demoing is not so important, but when you're machining the part in real life, I can see that the upper level is, this is because when I cut the outside, I never finished the outside. I left the wall offset of 0.2 millimeters. And you can actually see that this operation found that the highest level of the stock is 0.2 millimeters. So a lot of really cool information that we're feeding to the user as he's programming. As I said, all of this stuff is about making the programming faster, easier, smoother in SolidCAM. So none of the tools here really change the toolpath out at the CNC because it's still iMachining. We haven't really done anything there with making it different for this stuff, but in the software now, everything's a lot a lot quicker, smoother, faster, more informative, all meant to get you finished to programming your part faster. All right, so I'm going to, I love the new, so I am going to simulate it in here. Let me slow this thing down a little. Okay, I already see something here I dislike. So I can see here that we have this little tiny piece of material here. Maybe this is okay, but there's also a high chance that this little piece of material, when the tool comes and cuts it, it's gonna, it can either break off. When it breaks off, it can damage the tool. Sometimes with these thin little pieces, you get like chatter, and then maybe that could damage the teeth on the flutes of the teeth on the end mill. And so, I mean, if I continued simulating this, you can see what we get, right? That's not nice. Like, that for sure in the CNC is not going to sound very very good. So I started programming this way, and I'm like, okay, I want to change this. In previous versions, you'd be like, I want to machine. Okay, maybe I want to machine these two faces. So I don't know, maybe use a profile cut. If you used iMachining, you might just make a sketch here, right? I mean, if this was, if you were programming this with iMachining, you might just be like, you know what? I'm just going to make a little rectangle here. I'm going to take this rectangle in the sketch. I'm going to make these two things, collinear, and then I'm just going to like make a little semi-open pocket that kind of lines up with my stock, and then I would that as my chain for 2D iMachining, and then I'd mark these 3 edges as open, and I would try and machine that little face away, right? But now things are much simpler. So I can come to this operation. I can highlight my 2 faces, which this is really nice. You can pre-select your faces, and then you can say 2D iMachining. If you have pre-selected your faces, we automatically put them in the face list, so you don't have to pick them. So you can do kind of pre-select, kind of, let's say like SolidWorks, sketching, or SolidWorks features. If you pre-select a sketch and then go to extrude, it automatically uses that sketch. You don't have to pick it. So we're trying to do the same thing, making things be a little bit more intuitive for you. So we'll go select let's go select our tool. I'm going to pick my first tool. I mean, the preview here is just awesome. I mean, see, this complex stock, it automatically found the region, found the thing. I'm just going to calculate my toolpath. My toolpath cuts that material away. We can see the updated stock showed it. We come to our operation we created before. All I did was open that operation up, and you can see the dynamic preview automatically updated. So we can see that the preview automatically updated because the updated stock changed. All I'm doing is calculating the toolpath. You can see we get our toolpath just in the corner, because even though there's material down here, it's not less than the wall offset. We can go into the new simulation. Now for me, that looks awesome. I can see for sure, cutting parts long enough, I know that this is going to be much happier in the CNC than what I was doing before. Now, I said before, we a lot of times don't do save and copy. Here's a good example of using save and copy. I know I have the exact same feature on the exact same side, so I just save and copy. I think it's Mac 1 position 3. Yes, it is. Now I'm gonna up the entity here to here. One important thing, when dealing with an open profile like this that isn't closed, we have to decide what side of the geometry we think the customer is trying to machine. We pick the left side of the geometry. So I picked my chain this way, so that way I gave the iMachining feature recognition a hint that said, hey, try and find the area to machine on this side of the geometry, not on this side of the geometry. These are things that I think we'll get better with our feature recognition as we go along, but it's something to pay attention. You know, I think almost everybody here is used to picking chains, so you're cutting on the left-hand side of the geometry, but just something to think about. I will pick this vertice, save and calculate. We got our toolpath. It looks good. I'm happy with it. I don't need the same. Okay, now I'm looking at this part. I got a couple more things I want to show here. Really three more toolpaths. So first thing, we got this little tiny undercut underneath here, right? So the first operation when we machine this flat floor, it protected against that, and now we got to deal with that thing. So we're going to do that now. And we're going to go 2D iMachining. We're going to do feature recognition by chains, because I think everybody should start learning and asking yourself, okay, if I'm going to machine a feature, do I have a floor to pick, like a face I want to machine to, or do I have some walls or some a profile I want to cut? In this case, it's a profile. I think this is Mach 1 position 5. Yes, it is. Okay, so Mach 1 position 5. Okay, now what am I going to do here? I am going to here to here. Now the cool thing, we can show the updated stock from the cam tree. So this really helps while you're doing chain picking and thinking about what you're going to do. Because what I want to do here is I'm going to choose point to point, and I'm just going to pick a point somewhere outside here. So my chain is the lines I want to cut. But now we also have this edge here, which is partially finished from one of the previous operations. So what I'm going to do is I just did point to point just to get it somewhere else, somewhere past it. And you're going to see the 3D preview is it's smart enough to know that the stock is only here and it's only going to cut to this point right here. Now I'm going to do the same thing on this side. So up to entity, I'm going to do here to here. We are going to do point to point. So I'm going to pick something out here. Now, if you remember what I said just a moment ago, I said we always want to be on the left-hand side of the line to help the feature recognition, to give it a hint. So obviously the left-hand side of the line is up here. So I want to reverse this. So that way I'm giving a hint of, okay, the area that you're going to find should be on the left-hand side of this. I'm going to pick this. I am going to go select the tool. I have this 6mm end mill. I need to pick the depth too. So once again, we can see the updated stock. So it's so cool that you can kind of get an idea of, what you want to cut to and where you want to cut to. So I'm just going to pick that point there. I mean, obviously we didn't finish the wall yet, but if we were programming this for real, we'd be putting more finishing tools and stuff, but that would just be adding more operations in our cam tree. I think is unnecessary for this. Let's calculate the toolpath. You can see both pockets are cut. The preview, which is really awesome, we show you the original geometry selected, but you can see the 3D preview that has the area that we're going to machine is trimmed up to the stock perfectly, right? So that looks good. Okay, maybe I can jump. I keep forgetting to hold control when I click on the simulate button to go to the new SolidCAM beta simulator. So we can just, and I mean, I know the old Solid Verify is really works great too, and this is all based on the same code, but the new simulator I think is so informative. I mean, and it's so pretty. The graphics, everything is very very nice in here. So I mean, this is just a really cool example of seeing how it's cutting. What's kind of cool about this is, when we think about cutting at the CNC, we talked about the ACPs before. And the ACPs have to deal with how much of the tool is engaged in the material. when we look at this cut here, when it first starts to cut, it's only engaging this much of the tool, and then as it goes to the very bottom, it's engaging more. Me looking at this and cutting with iMachining long enough, and I think our customers know this, you see and you go, when this cuts in the CNC, this might be a little, I might hear a different pitch and a tone when it's cutting at the beginning of the cut by the time it gets to the end. I mean, this is all related to ACPs and things like that, but when you see this stuff in the simulation, and I would say when it's clear that you can see it in the simulation, this is all just information that's getting fed back into the programmer as he's working, to understand what's going on, and maybe understand if there could be, I'm not going to say a problem at the CNC, but just a difference, because somebody might start cutting this, and they might come to the operator, the operator might run the program, come back to the setup to the programmer and say, oh, at the beginning of that cut it sounded not perfect, but then by the end it sounded a lot better. Well, okay, as a programmer, I would be able to, even show the scene how this cut looked and explain to him, yeah, there's in the beginning, we have, let's say 10 millimeters of tool engaged, and then it goes all the way down to like 15. So they can kind of, see and understand that. I'm down to 2 last operations. So last thing we have, I have this toolpath here that's roughing and finishing this floor. Now in 2019, we have all the cool drag and drop. So I'm going to drag this to this face over here. So you can see that this face was, I took the first toolpath, which was doing the roughing and finishing of the floor, and we just drug it to this face. And if you're using drag and drop, you can also get your dynamic preview out here from the cam tray. So if we zoom in up on this, we can see here that there's 1 millimeter of stock still left over. Okay, looks nice. We can see that it's cutting 15 millimeters deep. And the cool thing is you can see the preview, and obviously on this part it's pretty cool looking. Let me just turn off the toolpath. You can see that even though we picked this face, which is, let's say, kind of complex, right? It has like slots in it and stuff, that the machinable feature is actually a quite simplistic looking shape. I mean, it's really just, it got rid of this, it got rid of this, and this is the machinable feature. And when you look at the toolpath, you see that it just covers this entire area, and it machines it down. And then last thing to show is, let's say I want to do drag and drop, and this time I'm going to do drag and drop to multiple faces. So I'm going to drag to this face, this face, this face, this face. I kind of have a feeling I might have grabbed that one there. Let's see. I did, didn't I? Well, which is cool. You can see the recognition starting to do its thing. Let's delete that because that was not what I was looking for. One, 2, 3, 4. Sorry guys, I think talking at the same, I think actually the go-to meeting, and I think the go-to meeting is slowing up my computer, because when I'm trying to do this drag to this face, it is not happening the way I want it to, but that's okay. We'll just save and copy. Let's unselect, and now we're going to pick this face, this face, this face, and this face. Save and calculate. And let's just make sure all of this is working. Variable levels. Yep, okay. So now what's cool to see here with the machinable features, you can pick multiple pockets with different upper levels and lower levels, and for each of those faces, we are automatically finding the upper level and lower level for each one of them. You know, it's up here. You can see that we found 1 millimeter, and then it's going to 0. And the same thing over here, we have minus 15 because we already machined this face, and it's going to minus 40. So this is, I think, another nice thing that you can save the customer time, that they can pick multiple levels in multiple faces in one operation. And the machining order is done by the faces in the order that you picked up. And in the end, we can just dump the SolidCAM simulator. And yeah, that ends the presentation. Let's see, does anybody have any questions?
Okay, Anthony, I see there's one question written down there. I think you see it in the question list.
Let me see, open it up. Poll question. Hold on, I'm getting there. It's really, so funny. Undock from the control panel. I do not understand how to. How to use the correct user offset for iRough, iRest for iMachining this offset from Multitool. Andre, I'm not sure what is in the question. I mean, I can say now that in when you're using Multitool, when you use Multitool, a lot of the parameters are synchronized between each operation, and they're also shared between the operations. So like when you come to the second tool, you can see in the iRest data, it's going to have the previous tool, the previous wall offset, and the previous floor. So I mean, and this is maybe a little, this is maybe a little different with Multitool. In Multitool, basically in the background, we are doing kind of iRough, iRest, iFinish, but we kind of do it in a more straightforward way. So if you have a specific question about, iRough, iRest, and iFinish, you can ask me offline, and maybe I can make that a little bit more clear.
I actually think that'd probably be the best thing if we caught you offline as well. Anthony, all I can say basically is, wow, it really looks extremely powerful what we've done, what you've done here in iMachining, the 2D, making everything a lot more visible than it was before, a lot more understandable as well. Okay, I'd like to first of all thank you, Anthony, for giving me the webinar. And again, this has been recorded, and later on, the recording will be available in the reseller section on our website, as well as this part that was used. Anthony will give me the part, and I'll make that available to you as well. And one last note is, again, I'd like to just remind everybody to make sure that you've signed up for SolidCAM World in Orlando in May. Okay, thank you very much, everyone, and we'll see you again at our next webinar. Take care and have a fantastic weekend.
Thanks. Bye, everybody.
Bye-bye.